solving rationals. Look at, there's some nice, dark, make it a little bit better. Maybe I should change the color. Alright, so we're going to do almost the exact same strategy that we did when we were adding these. Alright, so here is an equation, so this is a whole lot similar to what we were doing before. We actually want to find out what that common denominator is. So what would the common denominator be in this situation? 20, right? Right? So instead of actually multiplying this one by 4 and this one by 5, we're going to multiply the whole equation by 20. And when we do that, what happens is the bottoms are going to cancel out. They're going to clear. All right, so we don't need those anymore. And so that gets rid of the fractions, which everybody usually likes, because there's very few people in the world that like fractions. All right, so I'm just, hey, that's what it is. So this 5 is going to go into this 20 and give me a 4. Is everybody okay with that? Yes. Yep. So now I'm going to take 4, which I'm going to put right here, and I'm going to multiply to those two things. So now we have 4x plus 4. Okay. This 20 is also going to multiply to this expression, but this 4 is going to go to this 20, and that's going to leave me with 5. So now I have plus 5x equals, now this 20 is going to go to this 3, but there's nothing to divide there or reduce, so that's just going to give me good old 60. But notice that the bottoms have cleared out, so that's why we want to multiply by that common denominator, so to speak, whatever you want to call it. And now this is just a regular old solving equation problem that you've done before and that we did a little bit earlier. So we'll add these up, do some little bit of work here. And divide by 9. 56 divided by 9. Let's see. I bet that's 6.2 repeating. Is that close? Yep. Okay. All right. So the main idea is to take these rational equations and multiply by that common denominator. All right, that's what we want to do. So let's try. Let's just make them just a little bit tougher here, of course, because that's how it works. 3 over x plus 7 over 2x equals 8. Try this one out. We'll just kind of progress. So, again, we want to find that common denominator, that thing we're going to multiply by. What would be our common denominator in this case? Not just x, but 2x, right? So that's what we're going to multiply by. We're going to multiply by 2x to each and every one of these things. We've got to make sure we go to each and every single one. So, when I multiply this by this 2x, what's going to happen here? Yeah, so the x's are going to cancel, and I'm just left with 2, right? So then 2 times 3 gives me 6. So there's that one. Plus, now I'm going to do the same thing. So now I'm going to go this 2x, this 2x. What happens there? We don't get 0, they cancel out. We get 1. Okay, so then that's just going to be 7. Oh, this is getting to be worse. Our x is disappearing. But don't worry, it comes back. What's 8 times 2x going to be? 16x. So now we have really that. So that's way simpler than what we had in the beginning. And all we're doing is just clearing those guys out of there.
Wait, why did the X disappear?
Why did the X disappear?
Yeah.
Because the X that was here canceled with the X that was there.
Oh.
And this 2X and that 2X
Oh.
went away. Okay. Good?
Yes.
Alright, so then we just got to divide by 16. You can tell I made this up because none of these answers ever work out. 13 over 16. That's a great decimal.
0.8125.
Can we leave it as a fraction, or do you want us to put it in a decimal?
Oh, I don't care. Whatever you want to do, it doesn't matter to me. How about 3 over x plus 2 plus 5 over x plus, x minus 2 equals 12 over x squared minus 4. Okay, this one gets a little more complicated. What should we do with this? Factor. So what do we get if we factor it? X plus 2, x minus 2. Alright. So now we've got that all factored down. So what are we gonna multiply this whole thing by so that everything goes away on the bottom? Yes. X minus 2 and x plus 2. Awesome. Oops. I'll just have to, I'll do this. I'll lasso this guy. Bring it down. There we go. Okay. So now I can multiply by x minus 2 and x plus 2. Okay, to this whole thing. All right. So what are we going to be left with? Very far left here. So we're going to be left with 3 times x minus 2. Good. Plus, what about the 5 thing? What's going to be left there?
5 times x plus 2.
X plus 2. Okay, equals, what about over here? 12. So again, we're multiplying by that x minus 2, x plus 2. That clears the bottoms. All right, gives us a nice, fairly clean equation to solve. So we're going to get 8x plus 4 equals 12. Oh my gosh. Oh, this is because I got this one out of the book. 8x equals 8, so x equals 1. How about that? Okay. Now, what they do, and I'll mention this just because it's what they do, they say, how about solving these graphically? All right. Well, it's okay to solve them graphically, but the only downfall is that the screen does get kind of messy. So let's try to do one that way so you'll see it. All right, so let's see. I gotta get maybe this does have to be up here. Oh, there it is. Let's go into here's decimals right here. All right. So to do this graphically, this one's going to be pretty much a mess, but we'll try it. So y equals. I'm going to put in the 1/2 of it, so I'm going to go 3 divided by x plus 2. Oh, that worked. Plus 2 plus 5 minus 2. So that's the funky graph I get right there. All right, vertical asymptotes. Okay. Now I'm going to come down here and just put in the other one. Y equals 12 divided by x squared minus 4. Okay. So let's get rid of this. All right. So the blue one and the red one, and I'm solving this graphically. So what am I looking for? Any ideas? Where they intersect. But see, it's kind of messy to see. All right? I mean, they're kind of crossing right there. So we can click on that. And it says it's 1, which is what I got, and negative 4. All right? But as I go up here, they get so close to each other, I don't really know what's happening. And out here, I kind of don't know what's happening. And out here, I don't know what's happening. But it looks like this blue one is just going to stay above that axis, and the red one's going to stay below, so I don't think it's going to cross. Same thing's going to happen here. Okay? These two are going to stay separated very, very minutely, but they're going to stay separated. Same thing there. So the only answer we have is this one. All right? But graphically, it's kind of hard to see because it's a mess. And there's just a lot of graph on there, a lot of curves. So it's tough to do these graphically. I probably would steer away from doing them that way. Okay? But they say you can support your results that way. I wouldn't ask you to support your results on these graphically because it's kind of messy.
Ask a question about the previous problem, the one where we hit the factor.
Let me go back to it then, okay?
Sorry, factor the common denominator on the answer.
Are we talking about this one right here?
Yeah, so you didn't have to multiply the answer at all, did you, on that one?
The 12?
Yeah.
We did multiply by the x minus 2x plus 2. It's just that it canceled out with the x squared minus 4 because that's what that was.
Okay.
That's the same thing, right? If you factor it.
Okay.
Okay. So I'm not exactly sure what happened to the. This is, oh, there it is, x plus 2x minus 2, and this factored to that. Okay, it went away when I dragged it down. So I did multiply it. It's just that what I multiplied was canceled out. Okay, let's try. Let's go with 2x over x plus 2 plus 3x over x minus 1 equals 7. So we'll do one like this. And so what is our common denominator? What are we going to multiply this one by? X plus 2 and x minus 1. I'll put it over here this time because. Okay, so here, here, and here. So let's see what we have left. So what are we going to multiply? So we have, this is obviously going to be 7 times x plus 2 times x minus 1. Right? Because nothing cancels there. Does that make sense?
Right.
Okay. What about here for this one? What are we going to end up with there? I know I'm going to have a 3x. So it'd be x plus 2 there. Good. And then we're going to go all the way over to here. I know I'm going to have a 2x, but what am I going to have left there? X minus 1. Nice job. So that's what we're going to have. Okay? Okay, so now we just got to work this out. My goodness. So let's see. I'll just work this way. So let's work this out. 2x squared, 2x plus 3x squared plus 6x equals, I'm going to FOIL this first and then multiply by 7. Are we good with what we got here? This is a 2x. Does that look okay? What we did? Okay, we're going to keep working on this. I'm going to combine those terms. I'm going to combine these terms. Move some things over. How come we set it equal to 0? It's quadratic, right? So it's an x squared. Only way we can solve it is to set it equal to 0. All right? Okay. Cool. Now how are we going to solve it? Factor. What's another way? Quadratic formula. You could use that because you got that from your other classes. Okay. Let's see. I think I'll factor this. All right. So let's see. Ooh, 14. Got probably 7 and 2 would be our ones to look at. So let's see. Any ideas where we should put 7? Ooh, nice. And then that's got to be a 2. So we have a negative 14. One of these has got to be positive. Any ideas of which one? Good job. Okay, so what are my answers?
Negative 7 halves and 2.
7 halves and 2. Okay, so in this case, I got 2 answers. Ooh. Okay, here, I have one specially for you to try. X over x minus 5 plus 3 over x plus 2 equals 7x over x squared minus 3x plus 10 minus 10. Okay, what are you going to do first?
Factor the n.
Factor the n. Okay, try it out. See what you...
Okay, so what you're actually doing is you're saying, and that's just one based on the other.
Okay, so what's our first step here? Factor this. What's it going to factor to? Okay, and then what? Okay, so that's what we're going to multiply by. Keep going.
And then x will multiply by x plus 2, because that's what it's going to be.
I'd have you do this, but then the cord doesn't reach that far, so.
And then 3 is x minus 5.
Because the x plus 2 drops out, yeah?
And then 7x just stays the same as it has been.
Sweet, I like that. Okay, let's keep going. You're doing great.
X squared plus 2x plus 3x minus 15 equals 7x. And then 0 out the equation by bringing 7x over to the other side, subtracting it. Which gives you x squared minus 2x minus 15 equals 0. And then you factor that out,
Okay, everybody agrees with that, huh? No, no?
I just had a question. So,
Oh.
We're not laughing at
when you get to the trinomial with 5x for the middle term, how exactly did you know to subtract 7x from that?
To be able to factor it out completely, you need to have the equation equal 0. And so in order to do that, you have to take 7x and bring it over to the other side. So then that side equals 0. Does that make sense?
All quadratics got to be set equal to 0 to solve.
Must have missed that in my last math class. I think we started with a factored equation before we set the products to 0. This is like the reverse.
That's because they were all pretty much set to 0 in that class. Okay. You can blame me because we did some of these. So we always want to set them equal to 0. Okay, when you solve them. All right. So back to the answers. Everybody says 5 and negative 3. That's it, huh?
No.
Yeah? No. Why?
I've got negative 5 and positive 3. Right, you solve those to 0, so that would make that a positive 3 and negative 5.
Well, then that. Go ahead. So wouldn't this be a minus and a plus? Though? You'd be switching them, right?
I got negative 5 and positive 3.
You see why? I think you just, yours would give us a negative or a positive too. If we did it that way. All right. Still though, nobody's saying anything. Go up, back up to this original equation. So what was one of our answers? Negative 3. If I put negative 3 in here, and here, and in here, is it going to be okay? Is it going to work out all right? What's negative 3 minus 5? What's negative 3 plus 2? Okay. What's the other answer? What happens if I put 5 right there? Uh-oh. Can we have a 0 down there? Nope. 5 is not a solution. Okay? Because when we put 5 into this equation up here, we get a 0. Can't have that. So we're only going to get an extra, we're only going to have negative 3. All right?
So every time we do these, we want to make sure to check in case one of them isn't correct.
You should kind of check them. Okay? And the reason why, and you really got, when we start to multiply by a quadratic, then sometimes what happens is you pick up what is called an extra solution or an extraneous. Here, see if I let me spell it out for you. I'm just going to start over. You get an extraneous, that's what it's called, solution. So you're getting an extra solution when sometimes you multiply to clear out the bottoms. So we ended up getting this 5, but when we put 5 back into that original equation there, we get 5 minus 5, which is 0, and that's where the problem comes in. So you need to kind of be aware that you could get some answers that are not correct. All right? I don't know how many of those you're going to get. You might not get any, but it could happen.
So in that case, you want us to write extraneous or?
I just want you to pitch the 5.
Okay.
Pitch the 5 and realize that the negative 3 is the only solution. Okay? All right. Any questions on that, how we did that? Yeah.
I have to be honest, I still don't understand why it's not negative 5 and 3.
Why it's not 5 and negative 3?
Well, no, just like saying that x is equal to negative 5 and 3. Then it says positive 5 and negative.
Okay, so here's the, are you with me on this part then?
Yeah,
Okay, so you're questioning why
it changes.
it changes. Because this is equal to 0. right? So x minus 5 is equal to 0. What would x have to be in order for that to happen? And same thing here, right?
Got it.
Okay. Yep. Those are all good questions. Make sure you ask. That's what. On page 285, any questions on there that you want? I mean, you guys probably see what we're doing as far as when you're assigned. Is there any there that you want to go over that we can do that's on your assignment? Besides 87, 88, I'll do 88 with you.
Just wondering why that number.
But besides those ones, is there anything there? You don't. It says to solve and check your results, so that don't check it as in putting it back in and figuring it out. Just check it to make sure that it's a solution, right? You're not picking up those extras. You know what I'm saying? I don't want you to go through a lot of work. Anything on there you're not sure about?
Got it.
They do want you to solve some graphically, but they're not as messy graphing wise, so it shouldn't be too bad to do. But we can do one of those if you want. They're on the next page. Man, I'm gonna run out of stuff to say. How about page 88, or page 88? How about problem 88? Let's take a look at that. Okay, number 88 on page 287. Since I gave you one kind of like this. It says, waiting in line. At a parking lot, the attendant can wait on 60 people per hour. People arrive randomly at an average rate of X cars per hour. The average number of cars N waiting to exit the lot is given by this little rational here. X squared over 3600 minus 6dx. Is there a power on that? Or is that just a little glitch on the 60x?
It's a comma because the rest of the sentence it says where x is less than 60. So it's like they ran out of room.
Oh, okay. Okay, A, approximate x when n of x is 8. So we're going to put 8 where this is. So here's my... This is what I'm trying to solve. Any ideas on how we should solve that?
Multiply both sides by 3600 minus 60.
Okay, so we're going to multiply everything by 3600 minus 60x. Alright, that sounds like a good idea. So we're going to get something like this. What are we going to get on the right side? What are we going to get on the other side over here?
X squared.
Good. Distribute. Ooh, 8 times 36.
2880 or 28,800.
Is that right? And this one's 48 0x. So now what are we going to do?
Move the we could set the equation to 0.
Got to set the equation equal to 0. What would be best, to move the x squared or the other stuff?
The other stuff.
Good job. We want to keep that x squared
Positive.
positive, right?
480 minus 28,800.
Oh, this ought to be fun. Factors of 28800. They give me 480. Wow. Okay, I know how I'm going to do this.
Huh? 480 is a factor of 3,000.
Let's see. Y equals 2. Oh, I want to make a table and I can't do that on here. Rats. Rats. Oh, he took out my other. Oh, rats. Guess that's what happens when you have illegal stuff. Okay. Well, he took that out. But if you go into your calculator, your graphing calculator, and you go y equals 28800 divided by x, and you make a table, you'll get values that will multiply to 28,800. And that might help us figure out which ones are going to subtract to 480. Okay, my old TI-89 thing is gone because the guy who messed with this took it out. Probably was borderline illegal, but alright. That could be why. Anyway, I don't have a graphing calculator, so I can't do it. Has anybody tried? Has anybody found these factors?
What's the y-axis we're looking for?
We're looking for, so if you use a graphing calculator and you type in y equals 28800 divided by x, right, and then you make a table, you know how to make a table? Okay, then you just got to, we want to find the ones that are going to subtract to 480. Do any of those subtract to 480? I'm glad we did this one. Where you lost?
Everywhere.
Oh, you mean using your calculator? Is that an 83?
84.
Or 84, I mean?
Yeah.
So did you go y equals 28800 divided by x?
Yeah.
Okay. And then you should have a table button.
Yeah. So the graph.
Yeah.
And I've got the table.
Right. So then, like, so your table,
Trying to find numbers.
so your table's like this, x, y,
Yeah.
and like, that's probably the first one on there, and then 2 would be this, and 3, I don't know, and then 4 would be whatever 4 goes in there. But the thing is that these numbers are your factors, so if you find any that subtract to 480, let me know. Did you find any yet? Well, I want to graph it then. I'll go back to this. Let's see. X squared minus 480 x. Oh, that's a minus, it's a plus. Plus negative 2, 8. God, Steve. 2, 8, 8, 0, 0. There's one answer right there. $53.9? Huh. So 53 point, yeah, 53.9 is one answer. And oh, the other answer is negative, so that's not even any good.
540 for each.
So 53.9 is one answer. I wonder if something went wrong on this, because that doesn't seem right. Eight times 36 is 288, right? Yeah?
Yeah.
Okay. I don't know, maybe that's their intention. So, approximate it to about 53, 54. So there's my answer. And then it says, interpret that. Well, X represents a number of cars per hour, so I guess about 54 cars per hour would be my interpretation.
What did you want to for X minus and X plus?
Here, I don't even think it factors. I couldn't find any. It's coming out to be a decimal, so that's why I chose to just. I thought I would just go graphic because it's way too nasty. 54 to get 8. 54 cars per hour for 8
Sure.
cars waiting.
It's 2C? Or 2A?
That's an A,
2AC?
and that's B. Okay, good thing we did that one because that's a mess. Okay. So that table thing on the calculator was not, I thought it would work, but it didn't. So we're better off to use a quadratic formula or graph it and find an answer, do something different. Because you can't even factor it. So anything on 285? Everybody's okay with what we're seeing there? Yep. Yep. Okay. Well, all we got left then is the supplement to take a look at and our quiz, and that is it. But I have to go run the supplement off, so yeah, I guess you get about a 5-minute break. So I'll be back in a couple minutes to do with it for you.
Did you just borrow the
Yeah, I just set the other side and stuff right there.
Sorry.